Hello, and we're going to finish up with lesson 2.02 on reasoning, arguments, and proofs, part 2. And this lesson may be a little bit longer than 2.01, but we'll see. We got a lot more material to cover. Again, don't forget to put your course and section number on all communication to me. Helps me help you faster. Now, the objectives in this lesson are to identify premises and conclusions in an argument, which we did a little bit of that in 2.01, and then identify and develop syllogisms and other valid arguments. That sounds pretty official. Look at all these terms. Some of them are new, some of them aren't. Argument, a set of statements called premises that are used to reach a conclusion. We've already talked about premise. We've already talked about a conclusion, but I'm going to read this anyway. In an argument, the answer that is reached at the end of the statement of premises. In a conditional statement, the words following the word then. That's very important to remember. Your conclusion always follows the word then. When you have a valid argument, that's an argument in which if the premises are all true, then the conclusion must also be true. Syllogism. They even taught you how to pronounce it right there. Syllogism. A logical argument that always contains two premises and a conclusion. Syllogisms have the following form. If A, then B. If B, then C. Therefore, if A, then C. It's also known as the law of syllogism. And I read that kind of fast. Believe me, we're going over it in detail. The law of detachment. An argument that has two true premises and a valid conclusion. The premises and conclusion have the following form. If A, then B. A is true, therefore B. B is also true is what they're saying. Okay, arguments. A set of statements called premises that are used to reach the conclusion. Mathematical arguments always contain two or more premises and a conclusion. Okay, two or more premises and a conclusion. Valid and invalid arguments. Valid argument, an argument in which if the premises are all true, then the conclusion must also be true. When using deductive reasoning based on true premises, it will lead you to a true conclusion. Okay, so, and believe me, we're getting more into this in a minute. I'm just kind of introducing you. Valid and invalid arguments, and arguments can be invalid because the conclusion is not necessarily true based on the premises. And I put this little funny picture of Nicolas Cage down here. It says, "My hair is a bird." Your argument is invalid. I'm not quite sure what all that was supposed to mean, but it was a really funny picture. Okay, let's talk about syllogism and law of detachment. Well, we're going to just talk about syllogism first. Remember, it's a special kind of logical argument. It always contains two premises and a conclusion. Syllogisms have the following form. Okay, here's a premise. If A, then B. Here's your second premise. If B, then C. And then here's your conclusion. Therefore, if A is true, then C is true. Okay, and A and B and C all represent statements. Okay, and I'm going to give you an example. This is our dog Howdy. He's a bloodhound and we love him very much. Now then, here's a syllogism. Okay, if Howdy is hungry in the morning, then he barks. Howdy is hungry in the morning is going to be your A. He barks is going to be your B. If Howdy barks, then David wakes up. Howdy barks, if you look, is the B. Okay, David wakes up is the C. Therefore, if Howdy is hungry in the morning, then David wakes up. Howdy is hungry in the morning matches A in the first premise. David wakes up matches C in the second premise. So here's your conclusion. If A, then C. Okay, and I put some notes down here. It says deductive reasoning enables us to derive true conclusions from statements accepted as true. And remember, with your valid arguments, if the premises are all true, then the conclusion must also be true. Here's another example. If you are a baseball team, then you wear a red hat. So you are a baseball team is A, you wear a red hat is B. If you are a fireman, then you wear a red hat. So you are a fireman is C, you wear a red hat is B. Okay? Therefore, if you are on a baseball team, then you are a fireman. It says you are on a baseball team is A, you are a fireman is C. This is not, it's not, that's what I put, not. It's an invalid argument. Okay? Notice that both the premises can be true and the conclusion can be false. All right? And we know that not all baseball teams that wear red hats are firemen. That's how we know that it's an invalid argument. I mean, that's just common sense. And a lot of this syllogism is common sense. Kind of like the whale swimming as a fish. I mean, that's that whole example in the last lesson. It just took common sense to figure that one out. And I apologize, I got C and B switched here, but you can still see what's going on because you are a fireman is the new statement, which is C. Wearing a red hat matches B up in the previous conclusion. They will give you problems like that, so it's not just a mistake, it's real, but just getting you started out. I wished I hadn't flipped it. Okay, the law of detachment. An argument that has two true premises and a valid conclusion. The premises and conclusion have the following form, and right here's the form. If A, this arrow means then, so if A, then B, A, therefore B. And what they're saying, if A, then B, A is true, therefore B is true, is exactly what they're saying. This is just a mess up with the font. I meant to change all the fonts and I must have overlooked this one. This toy is a truck. This toy has 4 wheels. Okay, there's your A, there's your B. If A is true, then B is true. So look here, if this toy is a truck, then it has 4 wheels. This little box right here should have been a 4, by the way. Identify whether each argument uses the law of syllogism or the law of detachment. So we're going to get down to the nitty-gritty here and do some examples, which is really going to help us understand this a little more. If the moon is full, then the family dog howls. If the family dog howls, then the neighborhood dogs bark. Therefore, if the moon is full, then the neighborhood dogs bark. What I like to do is just, when in the beginning, you need to break it down step by step. If the moon is full, then the family dog howls. See how I put the moon is full is A, the family dog howls is B. Then I went to the second sentence and I said, if the family dog howls, then the neighborhood dogs bark. The family dog howls matches B in the first premise. The neighborhood dogs bark is a new premise, so I call it C. Therefore, if the moon is full matches A up here at the top, then the neighborhood dogs bark is C, and it matches C there. So you have to remember, if A then B, if B then C, therefore A then C. So there's a whole lot going on there. Usually when there's a whole lot going on, you're dealing with the law of syllogism. So anyway, you see how I broke it down with all the A's and B's and C's? Well, then it is easy for me to match up with the law of syllogism. See how that works? And by the way, there is the answer, law of syllogism. Okay, our next example says, if it is sunny outside, the weather is warm. Today is a sunny day, so it is warm outside. So remember, first I'm going to break it down. If it is sunny outside, the weather is warm. Sometimes they leave out the word then, and that's quite alright. Now our second sentence said, today is a sunny day, so it is warm outside. Well, all they did was say the same thing in a different way. Okay? They're talking about it being a sunny day matches it being sunny outside. So it is warm outside matches the weather is warm. Okay? So just all I've got here is A's and B's, no C's. When you have C's, you got syllogism. So I compared that with my little note on the law of detachment. If A, then B. If A is true, therefore B is true. So that makes it the law of detachment. This one says, for each set of statements, make a conclusion if it is possible to do so. If it is not possible to make a conclusion, then explain why. A relief pitcher in the Major League Baseball should not pitch 3 days in a row. Hector Santino is a relief pitcher. He pitched on Wednesday and Thursday. Well, it says here they can't pitch 3 days in a row. So if I look at Hector, he pitched on Wednesday and Thursday, so that tells me he can't pitch on Friday. So that's my conclusion. He's not going to be able to pitch on Friday. Hector should not pitch on Friday. And it says if it's not possible, then explain why. So we don't need to do any explaining on this one. If the diagonals drawn from one vertex of a figure to other vertices form 4 triangles, then the figure is a pentagon. Hunani drew 3 diagonals from one vertex in her figure. Okay? Well, if you look up here, they're talking about drawing diagonals in a pentagon. So this is what I did. I went from one vertice and I drew diagonals to the other vertices. Okay? This one is already drawn, going from the top to the side and the top to the side. Those are already drawn. But if you look here, there's 3 triangles. They were talking about a pentagon and said it formed 4. So right there, my premise isn't even true. But then it says Hunani drew 3 diagonals from one vertex in her figure. There's no way for me to draw 3 diagonals. So my conclusion is false as well. Sometimes you got to do a little extra work on the side. So it said, it is not possible to make a conclusion because the first premise is not true. So as soon as I drew this pentagon and was only able to make 3 triangles, I knew it wasn't possible to make a conclusion. Your summary: an argument is a series of statements that is made up of 2 or more premises and a conclusion. A valid argument is an argument in which the true conclusion is logically derived from true premises. Valid arguments follow specific patterns such as the law of detachment and the law of syllogism. I want to encourage you to be sure to go through the LMS lesson 2.02. It has a lot more examples in there for the syllogism and detachment and reaching a conclusion, and they're very good examples. I just didn't want to repeat them in the video. I wanted you to be able to go in and work them in the LMS. So be sure to go through lesson 2.02, completing the study guide, also reading 33 through 35, and be sure to complete problems 13 through 25 odd in the problem set. And don't forget, you have a key. So look at the key to make sure your answers are correct, because that's how we learn best, is from our mistakes. Contact me or attend TOGA if you have any questions before you complete the quiz, and then make note of any questions you may have for when you attend CC on Thursday. And I appreciate you listening, and we will talk to you later.